of Australia's most pristine beaches, a huge power plant is not an option. Instead, they're plugging into the largest electrical grid in the region, 55 miles away near Melbourne, with one of the world's longest underground extension cords.
So when you look across the gorgeous landscape, you actually won't see poles, you won't see power lines.
That's correct. Over 50 plus miles of cable completely hidden underground.
That's right. All you'll see is grass growing where the cable was buried.
So the whole idea is that to get the plant what it needs to get its electricity, to do it with as little impact as possible to the landscape.
That's correct.
Rather than bury a 220,000 volt power line in the soil where groundwater could short it out, crews bury plastic tubing and then thread the cable through it. The plastic keeps moisture away from the power line.
This is fancy stuff.
Yeah.
I mean, you don't want to just yank it, tear the cable.
No, very expensive cable.
And there are multiple lengths of cable along the run.
Yes.
You are being incredibly careful with how you move this run of cord.
Yes, very careful.
You spend a lot of time worrying about this cable going
I spent, very many sleepless nights in the beginning, believe me.
The tubing is a half-inch thick, weighing almost 8 tons. Workers first lay it into position and then cover it with soil. They then thread an almost mile-long cable segment through it. From the front, they pull the cable with a winch system. And from the back, a machine called a caterpillar pusher drives the cable forward.
It's actually a very large, multivalent, coordinated effort.
Yes, it is.
To pull with the right amount of pressure, squeeze the right amount of force, and do so along a very long length of cable.
Yes.
The cable is now halfway through the 4,000-foot-long tube. To reduce strain, they double their effort by engaging a second caterpillar pusher.
When I engage it with this torque wrench, these teeth will then come together, squeeze the cable, and assist it along the left.
Right. All right. Exactly.
Here we go. Crank it up, baby. Torque wrench coming. And you hear, as I crank this torque wrench, you'll notice these calipers are coming in. They're getting a little tighter.
You hear it start working now?
It's getting there. Tighter?
Yeah, you're going. You're all right. Keep going.
Oh, there we go. Heard the click? That means this pusher is engaged, collaborating with that pusher, ensuring the winch at the very top of this cable is not exceeding or pulling too hard.
Each additional foot of cable increases friction between the power line and the plastic cover. If crews did nothing, the friction could snap the cable.
Because I guess every single inch that this thing travels inside to a conduit, that's a moment for this thing to drag.
That's it. It just keeps getting higher and higher and higher. More and more friction.
To prevent the cable from tearing, workers apply a continuous layer of a universal stress reducer.
Oh yeah, that's nice. Look at that. That is just a nice. This is a soapy. It feels like lube really.
It is. It's polywater J lubricant.
It's lube, yeah. Not gonna try and call it something it's not, am I? All right, so let's get this guy going here.
Applying the lubricant reduces friction by 10%.
So you want to get it all the way around, all 360s. As this cable travels down, it could roll in the conduit, so we want to make sure we've got plenty of lube.
Plenty of lube, yeah. Don't want to be shy with the lube, right?
As funny as it may seem,
There's details to it.
it's pretty critical.
Now, it may look absurd what I'm doing, but the truth is, I'm actually going a long way to minimizing friction and reducing the force on this cable. But keep in mind, this cable needs to travel, quite literally, for over 50 miles to deliver electricity from the power station to the desal plant.
Melbourne's reservoirs are 52 miles away from the new desalination plant that'll make 1/3 of the city's drinking water. So to transport more than 3 billion gallons of water each month, crews are laying miles of pipeline across some of Australia's most complicated terrain, including 3 rivers and 38 roads. Until now, they've dug and covered the pipe in 10-foot deep trenches. 20 miles from the reservoirs, they've hit an obstacle. A 250-foot wide canal essential to the local farming community.
Under a typical set of circumstances, to lay a water pipeline, you would just scrape the earth, have an open cut, and lay your pipe. But in this case, there's a set of channels up there that are required for this area. And so while you're building this pipeline to get to Melbourne, you can't disturb it.
That's right.
So if you can't go through it, I guess the answer,
you
go under it.
Correct. This area has some of Australia's softest earth. Great for farming and agriculture, but not so good for digging a tunnel.
Should we head in?
Let's do it.
right, we're heading in.
The team is using a tunnel boring machine, or TBM. They must hit a target 360 feet ahead without drifting more than a quarter inch up or down. Now, when boring through solid rock, the TBM is fully supported. A driver makes just minor adjustments to stay on course. But in this soft earth, the 100-ton TBM is constantly sinking. So to stay on track, the driver has to constantly steer it through the mud.
Coming in. Oh, the front door you got here, Rob.
After digging nearly 350 feet, the TBM is just 10 feet away from the end of the tunnel.
All right, Robbie, so let's fire her up. You have your forces here, you have your vectors and your headings there. You got a level that says start, stop, and the title is cutting wheel.
That's it.
And so when you see that conveyor belt going, that means the cutter head is mining the rock.
The 12-ton cutter head tips the TBM down into the mud. Robbie has to steer it up to stay on course.
You're really driving the thing.
Watching every time I see what's happening to the cutter head, because it can sort of just suddenly change on you, so you've just got to be on it all the time.
To make the breakthrough, Robbie has to pass through a steel ring just a half-inch wider than the TBM.
So you're about 2 millimeters below where you want to be.
He's like Steve Prefontaine, he's hit his kick, he's going that last bit of the race, we're going to back up with the pipe, and he is going to bring this thing to the bullseye, the end of the road.
All good, all good, forget now.
Less than a foot of earth separates the TBM from the breakthrough.
So we're in the car, cruising over to the other side of the tunnel to actually see it bust through. Come on, Raj, hit it, baby. Raj, hit it, come on. Is it in there? Breakthrough? This way? Totally, Robbie is right behind the steel plate.
Everyone get clear. It's about to go through. Neil, it's about to go.
Alright, yeah, guys, yeah, ready? Here we go, man. He's ready?
Yeah.
Alright, here he comes. You can see Robbie's coming through right now. He's coming through the wall. Check this out. You can see the soil's breaking apart up top. Come on, Robbie. There's the water. It's like some medieval monster. Belching and burping. It's like a beast. The entire face is starting to buckle right now. It's like something out of a science fiction movie. The entire circle is starting to bounce a little bit. Push, there's smoke coming out, water's blowing out. Oh, here it comes, look up, top, it's coming through. This is it. Come on, Robbie. Oh! And we have breakthrough. That was amazing. The entire thing just came out. That was incredible. Robbie right to the edge, putting all the pressure on. The face finally opens up. All the earth comes crashing down, and behind me, there it is. Come on out, Robbie.
How are you doing, gentlemen?
How are you, sir?
All good.
So, after 360 feet, 120 meters, directly under a stream, you made it through, had a perfect breakthrough, and within a matter of millimeters. Well done, sir.
Thank you.
Really, congratulations.
With the tunnel drilled, crews have to now install concrete circular segments to hold it up. They use a technique called pipe jacking. First building each 13-ton segment, then pushing one into the other until 40 total segments support the entire 360-foot-long tunnel.
It's amazing. You're not actually building a tunnel piece by piece. You're actually loading a tunnel and then pushing the entire tunnel forward.
Yeah, that's right.
I mean, the whole thing
So
travels.
there's a lot of force.
39 segments, stretching more than 350 feet under the canal, are already in position.
So what's about to happen is that they're going to install the 40th and final pipe section. And to do that, they're going to take these huge jacks, retract them all the way to create a space, which is essentially right over here. And in this space, they're going to drop the tunnel section down. And then with these two jacks and a potential 1,000 tons of force, push the entire tunnel to the finish line. Here she comes, the final pipe section. A 360-foot-long tunnel, and that right there is the final 9 feet of the entire length. Look at that. 13 tons of solid concrete. We'll bring it right into place, fix it in between the previous 39 segments and the pushing ring, and then begin the process of pushing the entire tunnel to the last very bit of this distance.
No, stop Push on through.
So as you can see, he's advancing the jacks right now. By putting pressure on the section, he's moving this forward, and he's going to close this gap right here, getting this tunnel sealed and ready to climb. Look at that.
You're losing it. Keep up. Keep up, man. Keep up.
Look at that. Closing up right there. A little more, and look at that. We have contact. So now the 40th section is connected to the 39th section, which means the entire 360-foot long train is ready to move. It'll take the jacks 3 hours to push the 40th pipe section 13 feet, completing the tunnel. In just 8 months' time, the largest desalination plant in the southern hemisphere will be ready to provide water to 1 million Melbournians, whether it rains or not. I think a lot of people don't realize that water is not a plentiful resource that will forever be in abundance.
Victorians know that only too well.
And so the idea of having a consistent, large amount of drinking water there for the entire community, that's a huge development.
Yes, I think the children of the future have an obligation to understand about our use of water and what we need to do to supplement naturally occurring resources. So this will be a model for the future, I believe. We need to guarantee Victoria's water future, and we believe this plant will do that.
The issue of climate change is an incredibly complicated and global issue. But for Australia, the statistics are clear. Over time, their temperatures will rise. And over time, their rainfall will decrease. So whether they like it or not, the issue of water